In this part, we are presenting the simulation results for the cascade control. We shall also compare these results with the results for the single loop control and for the feed-forward control. As before, we shall compare the results for the reference tracking mode and for the disturbance rejection mode. The simulations for the single loop control and for the feed-forward compensation have already been presented. The results were saved and will be in this part used for comparisons. Let's start with the cascade control for reference tracking mode. This is the part of the program, and this is the universal scheme. Again, we can see the main controller, we can see the auxiliary controller here. Both feedbacks are active in this case, so these two parameters are set to 1. The feed-forward compensation is excluded, namely the disturbance is 0, and this gain is also 0. This is the part for the criterion function evaluation, and the reference signal is set to 1. We can here find some parameters. So the auxiliary P controller is set to 2, and the main controller is set to the parameters which were obtained with the optimization of the cascade structure. We have here two sets of parameters. This is set for the reference tracking mode, so the P controller, this is the integral constant and the derivative constant, and we can see that with this optimization the criterion function changed during the optimization from 89 to 24. Now I will select this part of the main MATLAB program, which is intended for cascade control for the reference tracking mode. I press F9 and I obtain two curves. The red curve is the curve which is intended for the cascade control, and the blue curve is the curve which was realized with the single loop control with the parameters which were optimized with computer optimization. We can notice the big difference. The cascade control enables much faster response. The overshoots are pretty similar, but the settling time is much smaller in the case of cascade control. We can manually trace the values which define the settling time for the red curve somewhere here. So we can find that the settling time is approximately 30 minutes, but for the blue curve it is more than 43 minutes. Let's trace the peak values of both responses. For the cascade control, we can find that the time is approximately 11 minutes. The overshoot is about 10%, and for the blue curve, for the single loop control, the time of the overshoot is approximately 15 minutes, and the overshoot is approximately 8.5%. In the last part, the cascade control for the disturbance rejection mode will be presented. So in this case, the reference signal will be put to 0 and the disturbance signal will be active, so Z will be 0.5. The KPZ will be 0 because we did not include the feed-forward compensation in this study. The parameters of the main controller were obtained with computer optimization. The criterion function was used in this optimization, And we can also find the parameters which were obtained with this table. For the disturbance rejection mode, we obtained the gain of the P controller, then integral constant and derivative constant. And in this study, the criterion 16 was at the beginning, and after optimization 2.3. Now I will select this part of the program, F9, and I obtain two graphs. The first graph presents the controlled variable, that means the level in the third tank. This is this value. And the second graph presents the control variable. This is this variable, which is the flow in the first tank. In this first graph, we have three responses: the green for single loop, the blue for feed-forward compensation, and the red for cascade control. We can notice that the behavior is, of course, the best with the cascade control. Of course, this is the optimal solution, which means that the disturbance do not influence, and the closest to this is, of course, red curve. So these peaks should be as small as possible. We can measure these peaks. In the case of single loop control, this peak is approximately 0.09. For feed-forward compensation, 0.05, and for cascade control, 0.03. So the advantage is really very big. And this graph shows the control variable. Again, green for single control, blue for feed-forward compensation, and red for cascade control. What we can notice if we zoom this initial part of the response, we can notice that the single loop control starts with control signal 0, but the feed-forward compensation and cascade control start with the value of the control variable -1. And this is also the stationary value. So the beginning value is the same as a stationary value, and this is the reason why cascade control and feed-forward compensation methods are so successful for the disturbance rejection.